Okay, here we go. Here we go. We're going. Everyone's favorite part of school, learning things. That's right. So here we go. All right. There's our equation. Now, with this equation, right, we could use what we did yesterday with finding a common denominator over here on the left-hand side, right, and then combining like terms. We have one fraction over here, one fraction over here, and then cross-multiply. We could do that. I'm going to show you an alternative way of doing these, okay? So I'm going to show you an alternative way, okay, rather than the cross-multiplying way. So yeah, we'll see how this goes here, all right? First of all, I'm going to rewrite this as 1 over 1, really, right? Because it's 1, but it's really going to make it 1 over 1. Okay, I don't know if that screws up some of y'all. Now that looks like a big plus sign. Guys, whoever's playing music, knock it off. Thanks. All right, so 1 over 1, all right, is what we got there. So looking at our denominators here, with this new method we're going to do, we're going to rewrite every denominator. So we're going to get a common denominator across the entire equation. Okay, so again, when we do it, when we use cross multiplication, right, you only need the common denominator on the left-hand side here, right, and then you just cross multiply once you put your two fractions together. For this other method we're going to do here, where we're going to end up dropping the denominator, we're going to get common denominators for the entire equation here. Okay, so in other words, let's look at this one first, right? What is this denominator missing that these other denominators, well, that this denominator has, for example? X minus 5, right. So we're going to take our denominator here. And multiply by x minus 5 over x minus 5. Okay? What is this denominator missing that other denominators have? What's this one missing? An x, right? So we're going to multiply by x over x. Yeah, so the 1 over 1, right? The 1 is missing both an x and an x minus 5. So I'm going to run out of space here, but we're just going to multiply by x times x minus 5 over x times x minus 5. I didn't leave myself enough space. Okay. So 1 times this. Then multiply the x's, so we get minus 8x over x times x minus 5 equals, and then here I'm going to go ahead and distribute the 3. So I'll get 3x minus 15 over x times x minus 5. Okay? Now, we'll take one more step here and combine these two fractions over here together since they are common denominators, right? And so I'll go ahead and distribute the x as well. So I'll have x squared minus 5x, but then minus the 8x, right? That minus distributes up to the 8 there, so it's minus 8x all over x times x minus 5. So again, I just distributed there. Okay, just like that. And again, I can put the minus 5x and the minus 8x together. I will do that here in a second. But at this point, I want to just pause real quick, okay? So any questions up to this point? For the most part, it's pretty standard. The only kind of weird thing that we did here was we got the common denominator for the entire equation. We rewrote the entire equation using the same denominator as opposed to just like one side here, okay? No questions up to this point? Now, we're back to our old scenario where we could cross multiply here. We don't want to, though. I've made it more difficult to cross multiply this path. But we'll look at this fraction right here, all right? And it's equal to this fraction right here, right? Now, these two fractions already have an equal part, right? The denominator of this fraction is the same as the denominator of this fraction. And we are also saying that the overall fractions are equal. So if the overall fraction, the entire fraction here, is equal to this entire fraction, and their denominators are also the same, what else must also be the same? If the whole fraction is the same and the denominators are the same, then what else must also be the same? The answer, okay, sure. We're going to get to the answer here. But what other part of the fractions must be the same? If the denominators must be equal and the whole fraction must be equal, what other parts of the fraction have to be equal here? The numerators. The numerators will also have to be equal, right? If we're saying that these two fractions are equal, the denominators are already equal, so the numerators also have to be equal. So we can kind of like just drop the denominator and just set the numerators equal to each other. Okay? Drop the denominator there. Because they're the same on both sides, you can just kind of drop the denominator. All right? And now it's quadratic. And in order to solve a quadratic equation, we have to be equal to what? 0. So we'll subtract the 3x over, add the 15 over, and I'll also combine the so negative 5, negative 8 make negative 13, minus another 3 will be negative 16. And then add the 15 over, so we get that. Okay. So again, I subtracted the 3x over. I added the 15 over. Okay. And now, how can we go about solving this equation? Let's factor it. Okay, we're looking for two numbers that multiply to 15, and they need to add to make negative 16. Okay, so what are those numbers going to be? Yeah, negative 15, negative 1. Okay, so x is 15 and x is 1. Okay. Do both answers work back in the original equation? Or at least do either of them make us divide by 0 if we plug them back into the original equation? They do not. So they're both good. They both work. Okay. There's our first example. Okay. So again, you could have, if you wanted to here, you could have just gotten a common denominator, and then on the left-hand side, okay, and then cross multiply. It'd be a little bit faster, potentially not. Okay. So you see the difference here today, right? So today we got a common denominator for the entire fraction. Okay, then we dropped our denominators and just set the numerators equal and solve from there. All right, questions on that? We're going to do one more here. Would anyone want to see this using what we did yesterday? Anyone want to see this done, what we did yesterday? Teresa's like, no, please. No more than we need. Anyone else, though? All right, if you want to see it later, okay, if you don't want to have everyone else wait on you, that's fine. Ask me later. I'll be happy to show you, okay? All right, we'll do one more then. At first glance here, right, do we have anything in common in our denominators? Actually, yeah? What do you say? Actually, yeah. Not square root it. We could do something to it, but with the way it's written right now, right, that is not the same as that, is not the same as that, right? All three of our denominators are different. But what can we do with x squared minus 9? It what? It factors, right? It factors. Okay, and what is it, Kobe, did you say what it factored to be? X plus 3 times x minus 3. Yes, very good, very good. Okay? Now we see, oh, there is more in common here than we first thought, right? There's more in common here. So you got to make sure you factor those denominators to get the pieces of it. Alrighty? So, looking at our denominators here, right? Again, we're going to use this method I'm talking about today where we get the entire equation have a common denominator, then we'll drop the denominators, right? So what is this denominator missing that this denominator has? An x plus 3, right? Okay. This one already has everything, right? How about this one right here? What's it missing? X minus 3. Okay. Multiply it out here, right? So I'll do this 6. It'll distribute. 6 distributes to the x and the 3, so we'll get 6x plus 18 over, and I'm not going to multiply out the denominator. Just leave it. Okay. Equals. And I have the 8x squared over x plus 3, x minus 3, minus, and then I'll distribute the 4x. So 4x times x, 4x times minus 3, so we get 4x squared minus 12x, again, all over x plus 3, x minus 3. Now, in the last problem, we got to this point. In the last problem we got to this point, I combined these two fractions together, right? We have the same denominator, we're subtracting, so I went ahead and just put them together. But actually, once you have that common denominator, you can now drop all the denominators with the way it's currently written. So in other words, I can go ahead and just say, all right, if this fraction here is equal to these fractions, right, and they all have the same denominator, we'll just drop that denominator and say it's 6x plus 18 equals 8x squared. The minus distributes. So it'll be minus 4x squared plus a 12x. So minus 4x squared plus 12x. Okay, the minus sign distributes there. And now what do we do? Where do we go from here? Make sure it's equal to 0. So get all your common terms together on one side. So we'll have 0 equals 4x squared plus 6x minus 18. Okay. So I got everything to one side. All right, and now what do we do? Can we take a GCF out? Yeah. It would be nice if it was 4, but unfortunately we have to do 2. Okay. Because we have this lead coefficient of 2 here, we'll have to use the AC method, right? We'll have to use AC method. We can't just say two numbers that multiply -9 and add to 3. We have to use AC method. So we'll do 2 times -9. Oh, sorry. Like that? We'll do 2 times -9. And that's -18. So yeah, we need two numbers that multiply -18 but add to make 3. So yeah, -3, +6. Okay. So I'll break up that middle term here. I'm going to run out of space. So group the first 2, group the second 2. What can we take out from that first group? What can we take out from that first group? From the first group? Just an x. And from the second group? What about that second group, folks? What can we take out there?
3.
A 3. Okay, we're on the right track, right? We got the 2x minus 3s there. I'm going to go this way because I'm running out of space. So we 2 parentheses 2x minus 3, and then the x plus 3 will be left over there. And again, remember, we've been equal to 0 this whole time. All right, it's factored and it's equal to 0, so we'll set each factor equal to 0, right? And so we get x equals 3 halves when you solve it, and x equals -3. Okay. do both of these answers work, or will one of them give us will one of them make our denominator undefined in the original equation there? Both of these answers work? Look at the original equation. Back to the original equation, the very, very original equation up here. Okay, so if I plug in 3/2 into one of these x values, will I get a 0 in my denominator? No. If I plug in -3 into one of these denominators, will I get a 0 in my denominator?
Yes.
Yes. So we want to throw out -3, and only 3/2 works there. Only 3/2 works. Whoops, I forgot to, well, that's good. Okay. Questions on any of this? Any questions? All right, so then I've got 2 here for you to try. All right, as well. Okay. 2 here for you to try as well. And you can use either method you want. If you just want to get like a common denominator on one side and then cross multiply, that's your choice. Or if you want to get a common denominator for the entire thing and then drop the denominators, that's another option as well. Question? Yep. All right, so there are 2 problems I want you guys to try. All right, so go ahead, take a couple minutes there, try these 2 problems here. Okay, again, you can use cross multiplication if you want, or you can drop the denominator. Okay, I'll do one way and I'll do one the other way. Going okay over here, guys? So, you want to look at your denominators, right? So you see you have a 2 in this one, an x minus 1, and x plus 1 in that one. Actually, it should be, that one should be x minus 1 now. So, look at this denominator. This denominator does not have x minus 1. So we're going to multiply this one by x minus 1 over x minus 1 to give it an x minus 1. Yep, that's really multiply 1. So then this denominator, it does not have a 2, right? This one's got a 2, this one does not. So we're going to multiply the top and bottom by 2. Okay? Now this one also, if you want to do a common denominator here as well, then this one also has an x minus 1, but this is 2, so we're going to multiply the top and bottom by 2. And then see what you do. Okay, go. Yes. Yep. 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 Yes. You get this okay? This struggle. These 4-day weeks are killer. See what? Look at this. I don't know. Should you be counting? I don't know. One day you'll be here, the next day you're not. That's all I know. I forget. It's like at the end of the, I don't know. I have no idea. Actually, I need to mark that down. Yes.
Why are all teachers wearing that?
Because it's Friday. Shuts down. I don't think we did this down. Other teachers wearing this one?
I'm sure that's similar to that.
Okay. I got this one switched off because like he gets all the Sure. Yeah, it's nice. Looks good. Yes. So distribute. You don't have to. So what you're doing here, the setup you have going on right here, I would recommend using like the drop in denominator thing. So you put at this point, since they're all the same denominator, you drop the denominator, just have 3x minus 3 plus 8 equals 2x over 3.
Okay, and then after that, you set it equal to 0.
Yep. Well, you want to solve. You're not going to need to worry about setting it to 0 because it's all within here, right? There's no quadratic. Quadratic. So yeah, just solve it. Whether we can get that there. Okay, Brandon, sorry, what's up? Yeah, that's right. Solve from there. Get your x's all on one side. So this is not quadratic. It's linear. So you can just solve like you normally would. It's only quadratic if you're going to be setting to 0, so that way you can either factor or put a formula. Yeah. Don't do that yet though. You want to combine your fractions together there so that we can cross multiply. Because you basically just undid what you did right here. You didn't have a common denominator, you got common denominator, then you refactored and started canceling, you went right back to where you started. You see what I'm saying? You kind of undid all your work you just did. So you don't want to do that yet. Combine your fractions together. Right here, then cross multiply. I'll give you a few more minutes here. Few more minutes. You know, they give like elementary school things like that, called fidgets, you know. I mean, it's fun to play with. Like, I just sit there, you know.
Yeah, I do the best. Actually, no, I've never been at work across, but.
You did here.
Yeah,
You did this part.
Okay,
Guys,
these are like
music. I mean, whoever it is, cut it out.
These are like actual notes in the
other words, you have to multiply this entire thing by x plus 6 over x plus 6. You can't like just bring in a plus 6, unfortunately. Like we just can't do it. That's why we have to multiply the entire factor x plus 6 over x plus 6. So that's the idea. All right, give you like another minute or two, like maybe 2 more minutes here, folks. 2 more minutes. All right, work on those 1 and 2 here. 2 more minutes. And then we will go over these. So yeah. Oh, I know what I can do too. I'll come check. Let me get this pile of papers here and I'll be right there. So, yeah, because when you combine two fractions, the denominators stay the same. Review your test. Test Tuesday, why?
No reason.
Is that too soon? It's a review for the test, so you can get a good idea of what to expect of the test, the scope of the test. Okay, I think I just used up the right amount of time there. So here are our answers. Now, number 1 and 2, you may have done a different method than I did. Okay, so you might have different work, but your answers should be the same. Okay. For example, number 1, okay, I did the cross multiplication method, okay, where I get a common denominator on just this side right here so that I can combine. I get a common denominator on just this side here so I can combine these two fractions together, okay, and then we can just cross multiply. Okay, and that gives this, where I bring everything over so it's equal to 0, I can factor. I get 2 answers, right? -3 and +1, but I can look back up here and see that +1 will cause me to divide by 0. So I don't want to include the +1, we'll just include the -3. All right, and then number 2, I did the other one where I got a common denominator for the entire equation. See, common denominators all around. And then I just dropped the denominators. So, and then I combined like terms. So it was the x plus the x squared plus 7x plus 6 gave me this, and the 13x there. Subtract 13x over, factor this, you get 2 and 3. Okay, 2 and 3. Okay? Questions on any of that? Okay, no questions? All right. What I also just passed out, okay, is a kind of like review for the test on Tuesday, right? This is just like every other review that I've given you in that. The questions that you see here and the questions that you see on the test will be very similar. In fact, in some situations, it's just the numbers that are different, right? So you should have no questions, no confusions about what to expect for the test on Tuesday, okay? At this time, I'm not going to give you guys any homework, but I would like you to work on this, okay? Or if you're not happy still with the score that you got yesterday on that like quizzes thing, I created another version of the assignment. You can't go into the one that we were working on yesterday because the time's up on that, and I don't know how to like make that work again. So I just came up with another one. It's the same questions, just I had to like reassign it, okay? So if you want to do better on that, I'll post that. Does anyone want to try and redo it to get a better score than what they got yesterday? Is Bella? Okay. Joshua maybe? Okay. So I'll post it up so you guys can like go to that if you want to. Okay. So one of these two things, either that quiz is yesterday, if you want to get a better score, or work on this, please. Okay. I have the answer key. I'm going to post this to Google Classroom in just a few minutes here once I finish talking. All right. Questions on any of that?
Can you put like everything on the board that like we're going to be tested on?
I have it here in the packet for you. This is it. These topics.
Okay.
these questions. Anything you see here will be on your test. Anything you don't see here will not be on your test. Okay? Other questions? All right. So please, let's get to work here, right? Let's get to work. All right. Oh, Brendan.